morning, Hamilton County 4th graders. Happy Friday. We've made it to the end of our first virtual week. I am really proud of you guys for the work that you've been doing. I'm super excited to see it. I have had a couple students taking pictures of the work they've done this week and have sent it to me. If you have not, please do so or email it to me. Or have I know that Dulce got hers sent to me through Miss Felicia. You can put it up on Dojo. You can put it through a private Facebook Messenger. Whichever way works for you. We just want to check and make sure that we're working through and we're going at a good pace and we're not falling behind. All right. Today we have a lot to talk about. You'll notice our packet for day 5 is incredibly thick. It has to do with time and money. We're kind of going to breeze through it a little bit, just touching base on a couple of things. We're not going to do it piece by piece though, because it is an extensive piece. I wouldn't have done all these pages with you guys in the classroom. We would have just kind of gone through it maybe in a day, maybe 2 days. But the extra pages are for your practice. If you don't quite have it down, you can go through those. But for the purpose of time and the purpose of not trying to overwhelm you guys, we're just going to kind of touch base here and there. So we are on lesson 24, time and money. If you will see, we have our standard for this lesson, which is 4.md.1.2. Use the 4 operations, addition, subtraction, multiplication, and division, to solve word problems involving distances, intervals of time, and money. Represent fractional quantities of distance and intervals of time using linear models. That sounds like a lot and it sounds super confusing, but all I'm really asking you to do is I want you to be able to solve word problems involving time and money. I want you to be able to convert larger units of time to smaller units in order to solve word problems about time. And I also want you to be able to convert amounts of money in bills and coins to solve word problems about money. And I left our lesson 23 vocabulary up because it's still pertinent. It's still, it has to do with what we're doing. Convert, remember, means to write an equivalent measurement using a different unit. So for time, we have hours, minutes, and seconds. This should have already been in your math journal from a couple days ago. If not, I suggest you look, I think it was day 3. Go back to that video and get that put up. At this point, we know that there are 60 minutes in an hour and 60 seconds in a minute, and it is very important for you to know that because these word problems that we're going to dive into today are going to be talking about converting hours, minutes, and seconds. Let's see, alrighty, here we go. Let's get the trusty old board out. Can you guys see that okay? So, I'm looking at page 260 in our book, our instructional book. Should say lesson 24, introduction. It says, last week, Sheen did chores for 1 hour and 15 minutes on Monday. So I'm gonna move my agenda over. So on Monday she did an hour, and that's HR per hour, an hour and 15 minutes is how long she did her chores. Then on Tuesday, we'll do that in a different color. On Tuesday, she did chores for 25 minutes. It says she spent a total of 115 minutes. So altogether, we did 115 minutes of chores between Monday, Tuesday, and Wednesday. I'm looking for a different color. Wednesday. Okay. So we want to know how many minutes out of this 115 did she do on Wednesday? Well, our first step is to make all of our units of time the same. We have 15 minutes, 25 minutes, 115 minutes. We have one outlier, one oddball, this hour over here. We need to change him into minutes. What would be my first step? Well, my conversion formula for time, for hours, would be hour times 60, because there are 60 minutes in an hour. So all we need to do is put this 1 up here and say 1 times 60 is 60. So how many minutes? We have, on Monday, we did 60 minutes. Let me change colors again. I need some fun colors. I might have to go buy me some expo markers. If anybody has any expo markers at home, feel free to ship them to the school for our lessons. All right, so I've got 60 minutes, but we also had 15 minutes. So I'm going to go ahead and add that in. Make sure you're writing your units of measurement. You should be writing this in your math journal. Should have already been out because you wrote your standard and your content objectives. And now you're writing this. All right, so we have 0 plus 5 is 5, 6 plus 1 is 7. So on Monday, we did a total of 75 minutes. Do we need to do anything to Tuesday? No, Tuesday is already in minutes. So we have Tuesday, we did 25 minutes. And all we need to do is add those two together. 75 plus 25 is, 5 plus 5 is 10. We carry the 1. 7, 8, 9, 10 is 100. So between, ooh, that looks weird. Between Monday and Tuesday, we did 100 minutes worth of chores. But for the Monday, Tuesday, Wednesday, we did 115. Remember, our original question was how much time did she spend doing chores on Wednesday? Oh my gosh. All right, so all we need to do is take this total amount of time, 115, and we subtract it from 100. Bring the 5 down, bring the 1 down, these cross out. So on Wednesday, she did 15 minutes. And we can always go back through and check by adding our 15, 75, and 25 together. And when we do that, we have, we'll do it down here, 75 plus 25 plus 15. 5, 10, 15. Carry the 1. 7, 8, 9, 10, 11. 115 minutes. Beautiful. Looking at the bottom of page 261 at the reflection, it says, how does the bar diagram help you determine how to solve the problem? So they showed you a bar model or bar diagram in the book. Ooh, I don't like that. Ms. Hotchkiss will show you a better one. All right, so we're going to do a bar model. We're just going to let it go all the way over. Oops. All right, and we're going to say Monday. We'll keep this. Monday, we did the majority of our time, so it's more than half of our time, because we did 75. So Monday, we did 75 minutes. Tuesday, oops, we did 25 minutes. And then this one was our unknown for a total of 115 minutes. And we could go through the same process. We add those two, get 100. We find out by subtraction that this would be Wednesday was 15 minutes. My computer tried to go to sleep on me at the first. That was the first time it tried that mess on me. Alrighty. Well, let's see. Going to page 262, you see another awesome bar model. Let's read this question. Sadie spent 58 minutes doing homework. So Sadie did 15 minutes, right? 58 minutes. Don't let me mess this up, guys. You're not in the classroom to help me when I misread something. 58 minutes worth of homework. She played outside for 20 minutes. 20 minutes played outside. And practiced the piano for 25 minutes. Piano practice. Does anybody know how to play piano? I know how to play one-handed piano. They call it the treble side because I used to play flute and French horn in high school, and we learned how to read sheet music with the treble clef, but I never learned how to read it with the bass clef. If anyone knows, I'd be interested in learning. Anyhow, how many more minutes did Sadie spend doing homework than practicing the piano and playing outside? Well, the bar model that it's showing us, so this is a comparison problem. It wants us to compare the time we did homework compared to the time that we played and practiced. So our homework, we did 58 minutes. For playing outside, we did 20 minutes. For playing piano, we did 25 minutes. We want to know how much more time we did homework compared to playing outside and practicing our piano. And we already know that we did way more homework than we did of the other two because look at our bar model. Our bar model goes all the way out to here. Our playing outside and piano practice only goes to here. So this chunk is where our answer is going to fall. Now what we can do is almost like the problem that we did just a moment ago, where we just took our total of minutes from our chores that we did Monday and Tuesday, and we subtracted them from the total minutes we did all 3 days. So what I'm going to do is I'm going to add these two together. 20 plus 25 is 45 minutes, and I'm just going to say recreational, which I don't know if practicing piano counts as recreational, but who's counting? And I'm going to take my 58 minutes that I don't want to do in that color. 58 minutes worth of homework. And since this is a comparison problem, we're going to use what operation? We're going to use subtraction. 8 minus 5 is 3. 5 minus 4 is 1. So we did 13 minutes more working in homework than we did practicing piano or playing outside. Looking down at number 6, the try it on page 263. Coach Douglas has it to plan a soccer practice that lasts 60 minutes. So, I don't know if this is going to work for this problem, but we're just going to say our soccer practice is going to last 60 minutes. Soccer. That's Miss Hotchkiss's really poor attempt at making a soccer ball. Anyhow, the team will spend 14 minutes stretching. So, 14 minutes stretching. Because stretching is very important. We don't want our muscles cramping up. And 29 minutes practicing passing. So, 29 minutes. It's going to be a little bit longer than our 14. 29 minutes practicing passing the ball. Some people need that extra practice. I did soccer when I was y'all's age, actually. And nobody on my team would ever pass the ball to me. I would get in so much trouble because I would end up stealing the ball from my own team just so I could get a chance to score, which I didn't. I wasn't that great at soccer. There was a reason they weren't passing the ball to me. Anyhow, the rest of the time will be spent on skill drills. How many minutes will the team spend on skill drills? So, here's our unknown. Okay, so just like how we solved the previous problem, we can add this together. 29 plus 14. 9 plus 4 is 9, 10, 11, 12, 13. Carry our 1, 2, 3, and 4. So we spent 43 minutes stretching and passing the ball. Our practice lasted how long? Our practice lasted 60 minutes. In order to find out this missing part, we're going to have to subtract the time we've already spent stretching and passing the ball. So when we subtract the 2, we got a bar because we can't take 0 from 3. So that becomes a 5. Carry our 10 over. 10 minus 3 is 7. Bring down the 1. So we spent 17 minutes practicing drills. Got it? Remember, if you have any questions, just comment them in Google Classroom, or you can call me, or we can chat on Facebook. One or the other. Whichever one works for you. I hope y'all don't mind me not using the document camera because I'm just kind of skipping through here. All right, number 7 on page 263. This is still the instructional book. The one we just did was number 6. Now we're on 7. Aaron spent 52 minutes riding his bike. So we're going to create that same model. We did 52 minutes. 52 minutes. Did it just say riding? Yep. Riding his bike. All right. Out of that 52 minutes, he spent 5 minutes of that time warming up, essentially stretching. Because stretching is important. 5 minutes stretching. We're just still going to say stretching. And another 5 minutes cooling down. So another 5 minutes cooling down, which is also important, especially if you're going really far or you've just been riding for a while. Like 52 minutes is a long while to ride a bike, especially if you like are on a bike trail that has hills and is dirt. It might take you a little while, and it takes a lot of effort. All right, so 5 minutes cooling down. He spent the rest of his ride practicing riding up and down hills. Told you there were hills. How many minutes did he spend riding the hills? Well, we're going to go through. Here's our unknown. This is how much he did going up practicing on the hills. Riding hills. So when we add our 5 minutes of stretching and our 5 minutes of cooling down, we've spent 10 minutes stretching and cooling down. Oops. Our bike ride lasted a total of 52 minutes. So we're just going to subtract. 2 minus 0 is 2, 5 minus 1 is 4. So we spent 42 minutes riding the hills. Once you get the hang of it, it starts becoming a lot easier. This one we actually didn't even have to do, neither one of those we had to do any kind of conversions with. So we lucked out on that. I do want to tell you guys something though. I just remembered. I had such a cool idea yesterday. I was helping putting together your guys' weekend lunch packets. And also you guys owe your food service team some big thank yous, because oh my gosh, we a handful of us teachers went down there and helped put your weekend lunches together, and oh my god, Ms. Hodgins thought her back was gonna kill her. I'm like, good Lord, you guys are planning on doing this every week? So when you see your food service people out there this weekend or tomorrow or this afternoon, make sure you say thank you. Make sure you express that gratitude, because they are working really hard, trying to make sure you guys have your snacks and stuff the weekend. So make sure you're being really grateful about that. Anywho, I had this great idea to try and get you guys to make sure you're watching my videos. Next week, I am going to, it'll just kind of be random. We'll be doing our lesson, and I'm going to bring out an Easter egg. And inside that Easter egg is going to be a math problem. If you answer my math problem, and you have mom and dad either message me on Dojo or on Facebook your answer, and your answer is correct, I'm going to send you something special. So be on the lookout. Make sure you're watching these videos all the way through. It's good stuff. It's stuff you would have gotten in the classroom if you were here with me, which I miss you guys so much. But I just want to make sure you guys are watching. Yeah, I think it'll be fun. What do you guys think? We'll see. We'll see. The first one will be on Monday, so make sure you're looking out for it. All right. We're on page 264 in the instructional book, Solving Problems About Money. This one, we're going to get into some decimals. And so I'm just going to put up here at the top my place value chart for decimals. I'm only going to go up to hundreds. So we have hundreds, tens, ones, tenths. We'll put a big, well, I don't want to put it at the top. We're going to put like a red dot to show you where the decimal falls. There we go. Yeah, you can see that. Tenths and hundredths. You also should have this chart in your, come closer. There we go. You should also have this chart in your math journal too. All right. So our question on the top of 264 is, Prim bought three muffins at the school bake sale. Each muffin costs 75 cents. She also bought a cookie for 50 cents. Prim gave Mr. Hall a $5 bill. How much change did she get? All right, so we have 1 muffin, 2 muffin, 3 muffin, and 1 cookie. And it's going to be a chocolate chip cookie because those are my favorite. Each muffin costs 75 cents. Well, 75 cents is how many quarters? It's 3 quarters. A quarter is worth what? 25 cents. Just so we're clear. So we have, I'm just going to break that up. Make sure you're noting that there's no dollars, just cents, okay? So this is going to look like got it? All right, same here. $0.75, and we're going to go all the way through. Boom. And our cookie costed us 50 cents. So our cookie only cost us 2 quarters. There's 1 quarter. There is 2 quarters. And that's going to equal 50 cents. Now, she gave Mr. Hall a $5 bill. So what we can say is we know that there are 4 quarters to a dollar. So I'm just going to go through. All right, here's 1, 2, 3, 4. That's $1. All right. 1, 2, 3, 4. That's $2. That's another $1, excuse me. And then we have 1, 2, 3. We didn't have enough, so to make a whole. And we're just going to add that up. Okay? Now when we're adding with decimals, we treat it just the same as a regular addition problem. The only difference is we make sure we bring that decimal point down here. So we have 0 plus 0 plus 5 is 5. 0 plus 0 plus 7 is 7. And then $2. So our total cost is going to be $2.75. Remember, we gave Mr. Hall, or she gave Mr. Hall, a $5 bill. She paid, or her total of goods was $2.75. Now remember, we want to go ahead and bring that decimal point down. That way we know where it belongs. All right, we can't take 0 from 5 or 0 from 7, so we're going to have to borrow $1. All right, and this would have been a 10, but we got to borrow again, so that makes it a 9. Then the 10 goes into the ones column. 10 minus 5 is 5. 9 minus 7, 2. 4 minus 2 is 2. So our change would have been $2.25. The book explains it slightly different. You'll notice that they're not really showing you where that decimal point is supposed to go. But in 5th grade, you really need to know this. And so, I did not put my operation. I just noticed that. Whew. Anyhow, in 5th grade, you're going to be working a lot with decimals. And so having the knowledge of, okay, the decimal comes down is very important. And that's why I'm showing it to you. So I really hope that you guys are watching this video and paying attention. All right. So that was the example problem. That should get you through 8 through 12 on page 265. Oh, I didn't want to erase that part. You right? That back. Come back, 100. It's messy, but she works. Looking at the bottom of 265 on the try it, number 13, it says 1 pound of nuts costs $2.80. So 1 pound, remember our abbreviation, of nuts is going to cost us $2.80. Aaron bought 1.5 pounds. So Aaron bought 1.5 pounds of nuts. Excuse me. He gave the clerk a $10 bill. All right, so this is what he gave the clerk. This is what he's paying with. A $10 bill. Can't really see my decimal point. There it goes. All right. He gave it. How much change did he get? Well, how much does 1.5 pounds of nuts cost? Well, we know that he spent at least $2.80 because that's how much a pound of nuts costs. But how do we figure out how much this half costs? Oh, did I do that right? Okay. Well, think back to when Miss Hotchkiss was teaching you about fractions and money and decimals. $2.80 is the same as saying I had 28 dimes, right? If I had 28 dimes, each dime is worth what? 10 cents. 10 times 28. Well, 28 times 1 is 28, and we have 1 0. We bring that decimal point down. $2.80. So just to make this slightly easier to look at, I'm going to take that $2.80 and I'm going to say I have 28 dimes. And if I want to know what half of that is, all I'm going to do is divide by 2, right? Because think of it. When I say, what's half of 30? 15. What's half of 10? 5. Well, that's dividing by 2. 10 divided by 2 is 5. 6 divided by, or not 6. I had said, gosh, what did I say now? 15. If I said 30 divided by 2, you get 15. So we're going to divide this by 2. 2 goes into 2 ones. 2 times 1 is 2. Subtract, bring down. 2 goes into 8. 4 times. 4 times 2 is 8. Subtract 0. So we're looking at $1.40 because I'm showing 14 dimes. And if I were going to multiply 14 by 10, 1 times 14 is 14, and we have 1 0. And we just bring that decimal point down. So a half a pound of nuts costs $1.40. And all I need to do is add in our totals. So 8 plus 4, 8, 9, 10, 11, 12. Bring that decimal point down. Carry your 1, 2, 3, 4. So the total for 1.5 pounds of nuts is $4.20. Whoop! I almost forgot to put my money sign. It's a weird looking money sign, but it'll work. But we're not done. We still have this $10 floating around. Remember that $10 is how much he gave the, what do they call the guy? They didn't call him anything. It's how much he gave the clerk. All right. So our total, $4.20. We're going to subtract 0. We can't take 0 from 2. We can't take 0 from 4. So we're going to borrow this 10, make that a 0. This would have been 10, but we still need to keep going. So we're going to borrow from that 10, make that a 9. 10 minus 2 is 8. Bring down that decimal point. 9 minus 4 is 5. So he got $5.80 back. The decimal, don't let the decimal mess you up, okay? I'm going to go back through real quick because this did have a lot. What I did was I knew Aaron had 1.5 pounds of nuts. I knew that 1 pound of nuts was going to cost $2.80. I needed to find out how much half of that was. So I took $2.80 and I converted it into dimes. 28 dimes is the same, is equal to $2.80. I took that 28 and I divided it by 2 to find out how much a half is. 2 divided by 28 ended up being 14. I have 14 dimes, which was equal to $1.40. And then I simply inputted the $1.40, found out how much my total was going to be. I gave the clerk $10. He subtracted my 10 from what I owed him, that $4.20, and I found out that my change was going to be $5.80. All right. Number 14. Keisha has $3,600. So Keisha just got paid, and Keisha got $3,600 for her paycheck. All right. Keisha's bills cost how much a month? $1,900. Okay. She puts half of that amount that she used to pay bills in her savings account. So before we go any further, I'm going to go ahead and find out how much this was after bills. So I'm going to subtract. I'm going to take $3,600 and I'm going to subtract my bill money out because my bill money is no longer there. I had to pay the light bill. I had to pay the internet bill. All right, we've got 0, 0. We need to borrow. All right, 16 minus 9, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7. There it goes. Like, that's not right. 7. 2 minus 1 is 1. So now I have $1,700 left, but I'm putting half of that in my savings account so that I got money to fix my car when my car breaks down. So my savings is I put half of this into my savings. Remember, when we're trying to find a half of a number, we divide by 2. So I don't want to do it in red. 2 divided by our leftover money. Don't go to sleep on me. 1,700. 2 goes into, we'll use pink. 2 doesn't go into 1, so 2 goes into 17 8 times. 8 times 2 is 16. We subtract. 7 minus 6 is 1. That zeroes out. And then we bring down. 2 goes into 10 5 times. 5 times 2 is 10. We subtract. That zeroes out. Almost done. Now we're going to bring this 0 down, this 0 up. Because 2 goes into 0 0 times. So half of our 1,700 is going into the savings account. So the savings account is going to get $850. So how much do I have left over? Well, if I had 1,700, half of 1,700 was 850. I put 850 in the account. I have 850 left. Boom. And you can go back and check by adding everything back in. If we added everything back in, we should end at the same number that we began with. So we want to add our bills back in, 1,900, and we want to add our $850 in savings and the $850 that we said we had left over. And we're going to add those back together, and we should come back to 3,600. Let's check. 0, 10, 9, 10, 18, 19, 20, 21, 22, 23, 24, 25, 26. Beautiful. Remember, you can always go back and check your work in math. That's one of the thing about math that I do like is I can check myself. All right, I'm going to pause the video there. And I'm going to start part 2 because we're already at 41 minutes. So I will be back to go over 266, and then we should be good. All right, bye guys. I'll see you in a second. Hello again, 4th graders. Coming back, part 2. We're on page 267 inside the instructional book. The guided practice for solving time and money problems. It shows you the example. We're just gonna jump right into it on number 15. It says, Steve swept the kitchen floor after he washed the dishes. Then he took out the trash. He spent 18 minutes washing the dishes. So I'm gonna go ahead and write 18 minutes washing dishes. Then this is 3 times as long as it took him to sweep the floor. So this is 3 times as long as it took him to sweep the floor. We're just going to put S for sweep. All right, I came up with a multiplication sentence for this. This is an S for sweeping. So 18 minutes washing the dishes. This is 3 times the amount, or 3 times as long as it took him to sweep the floor. It took him 3 minutes to take out the trash. 3 minutes, take out trash. How long did it take Steve to complete his chores? All right, well, in order to find out our unknown, we need to switch this equation around to division. So 18 divided by 3 equals the amount of time it took him to sweep. So it took him 6 minutes to sweep. So now we have 18 minutes washing the dishes, 3 minutes taking out the trash, and 6 minutes sweeping. They want to know how long did it take Steve to complete all of the work. So we just need to add up our 6, our 3, and our 18. So your problem's going to look like this. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So it took him 27 minutes. Now you wouldn't have gotten that if you did not do your equation right at the top, where it had said that he spent 18 minutes washing the dishes. This was 3 times as long as it took him to sweep the floor. All right, all I did was I switched these around and divided so I could find out my unknown. This was my unknown. 18 divided by 3 equaled 6. So we had 18 minutes washing the dishes, 3 minutes taking out the trash, and 6 minutes of sweeping. And that got him 27 minutes. Now you remember, Coach Harris said 30 minutes of inside household chores. Well, wash the dishes, take out the trash, and sweep. Boom. You're at 27 minutes. I'm sure Coach Harris will give you a little leeway on the 3 other minutes that should have taken. All right. Plus, doing dishes is great. It opens up your lungs, especially if you use really nice hot water. I like washing dishes, especially when my nose is stuffy. Number 16, Riley takes a yoga class that lasts 45 minutes. So the yoga class is going to last 45 minutes. 45 minutes yoga class. The class spends an equal amount of time to warm up and balance activities. The class ends with 5 minutes of relaxation. How much time is spent on the warm-up? Well, we have 45 minutes. We already know that we spent 5 minutes at the end for relaxation, so we're going to go ahead and subtract that 5 minutes out for relaxation. Ooh, I think I need to sign up for a yoga class. So that gives us 40 minutes to warm up and balance activities. So we have 2 activities here, warming up and balancing. I imagine they mean like a balance board or something. I've never taken a yoga class before. But if I did, I think that's probably what that would be. But it specifically says the class spends an equal amount of time. So here is warming up. And here is the balancing activities. These are equal. Well, I know that I have 40 minutes in my 45-minute yoga class that's going to be divided between these 2 activities. Oh, I said divided. That means there's an operation there. All right. What am I going to divide by, though? Well, I have 2 activities that spend equal amounts. So I'm going to do 2 divided by 40. 2 goes into 4 twice. 2 times 2 is 4. We subtract. Bring down our 0. 2 goes into 0. 0 times. So each of these activities was worth 20 minutes. So your answer that asks how much time is spent doing warm-up, 20 minutes. Easy peasy, guys. Easy peasy, lemon squeezy. Going to number 17. It says Victoria has 2 $20 bills in her wallet. So inside her wallet is 2 $20 bills. I know there's a president that usually goes on there, but I'm not fixing to try and draw him. We're just going to say 20. She spends $12.25 on a gift. So she spent, I'm going to write it in red, $12.95 spent on a gift. And $5.25 on a card. Oh, she must be going to a birthday party. $5.25 spent on a card, which people generally prefer you to get or do handmade cards. Don't be going out and spending $5.25 on a card. Make it yourself. Your art teacher will be super proud of you, and the people that you give it to are going to love it that much more because you put the effort in. All right. The question says, how much money does Victoria have left? It said circle the letter of the correct answer. Well, before we even look at those answers, we need to find out how much in total she spent. So remember our rule about that decimal point. We're just going to bring it right down. That way we know where it's at. And we're just going to add. All right, 5 plus 5 is 10. Carry the 1. 9, 10, 11, 12. Carry the 1. Did we do anything with that decimal point? No, it just stays there because all we did was we brought it down. So 2 plus 3, 2 plus 3. 2 plus 1 is 3, plus 5 is 8, and bring over the 1. So she spent $18.20. They want to know how much she has left over. Well, we have 2 $20 bills here, which equals what? 20, 40. $40. So she has $40 to start with. she spent $18. Whoops. Make sure you're lining your stuff up right. She spent $18.20. We're going to go through and subtract. All right, 0 minus 0 is 0. We can't take 0 from 2, and we can't take 0 from 8. So we're going to borrow. We can't make this a 10 because we're borrowing again, so we're going to make it a 9 and bring this over. 10 minus 2 is 8. Bring down that decimal point. 9 minus 8 is 1. 3 minus 1 is 2. We had $21.80 left over. Let's see. Oh, did I write something down wrong? I did. It wasn't $12.95. It was $12.25. So I did that wrong. Oh no. Oh no. I'm going to have to erase all of that. All right. Miss Hotchkiss, get it together. Make sure you're reading the problem right. All right. Now we're going to subtract again. Or we're going to add. That was 10. 5. Bring down that. 5, 6, 7. And 1. I did write the 5 right down. Yeah, I did. Okay. All right. So we actually had $17.50. My bad, guys. My bad. This is what happens when you're not here to be like, Miss Hotchkiss, look at the problem. $17.50. We'll go through. Still need to borrow. All right. Bring that decimal point down. 9 minus 7 is 2. There we go. There we go. That's the right answer, Miss Hotchkiss. So your correct answer would have been C, $22.50. It says Amir chose A as the correct answer. How did he get that answer? Well, he could have subtracted the amount Victoria had spent from just one of the $20 bills. If he forgot that she had 2, and he was only saying that she had 1, which could happen, you know. We're looking at $17.50, and we're not thinking about that other $20 bill because the first $20 bill would have been plenty, and we would have had $2.50 left over. But she had 2 $20 bills, and you have to be able to account for the other bill. All right. Whew, that's it in the instructional book. What's my time? Am I going over? No, I'm not going over. No, I'm not going over. All right. Let me pop over real quick. I just got to look at this email. Oh, okay. Noted. All right. Looking in the practice book, we are on page 259. It should look like that. We're not really going to jump into the example. We're just going to go straight into it. All right. It says fill in the blanks below with the number to show different ways to make 50 cents with quarters, dimes, and nickels. Ooh. You know what? I think we're going to do this. Oh, I think we're going to do this on the whiteboard. So I'm going to have to pop off and go into the computer. I will be right back.